number of items sold, and P is your price. So make sure you change that. You always want to state your variables. So for part A, you're asked for the demand function. So in the demand function, we have price and we have number of items sold. So let's say let X represent number of lattes sold, and we'll let P represent the price of one latte. So we're going to let N represent the number of price decreases. So our first equation, let's figure out what does X equal. X is the number of items. What equation can we use for that? Depending on the number of price decreases we do. We sell 500. And then what do we sell, depending on the number of decreases? Okay, but are we good? So plus 125N. And then we can get another equation. P, the price. What do we know about the price? So now, though, when you go back to your demand function is P of X. What do we have here? So what can we do to make this so that it's P of X? So we're going to rearrange this so that it says N equals. So if you rearrange, you're going to have X minus the 500 all divided by 125. So now you can substitute it in. So you have, change color, 4.75 minus 0.25, X minus 500 over 125. What you'd end up with is 5.75 and then minus, let me make sure, 0.002x. So where does the 5.75 comes from? That last distribution. If you multiply this and divide it by 125, you get 1, and then 1 plus the 4.75, because those are like terms. So for part B, our revenue is what we're looking for. If we go back to our definition of what revenue is, it is X times our demand function, or our price function. Well, we just found that. We found that right here. So we're going to do R of X equals X times 5.75 minus 0.002x. Good. 1,700 and what? Good. Perfect. So that would be the revenue. That would be how much you got paid for 350 lattes. What is the easiest way to take the derivative of this function? So we'll expand it first so that we have 5.75x minus 0.002x squared. So now we can find R prime of x, which is 5.75 minus 0.004x. And it asks for the marginal revenue at 350. So we can substitute it in. And so we should have got 4.35. And what does that mean? So this here, let me just switch colors. This is the total that you would have made for 350 lattes sold. Because this is the rate of change at one value, that is what you would make for one latte, because this is the rate for that value. So to find C prime of x, we have negative 0.001x plus 3.5, and then we were asked at 350 lattes. What would it be? So it costed this company $3.15 just to make the latte. So that will find the actual, or if you plug it into your derivative, sorry, 351, that will also get you the same value. So because doesn't make sense to keep all these decimals. If you're looking for the exact cost of it, you want to keep them, even though logically it doesn't make sense because cents only goes to 2 units. We know the equation for profit. It is our revenue minus our cost. That's your profit function. Perfect. Okay, now we have to find our marginal profit. So we have to take the derivative, negative 0.003 x plus 2.25, and we have to find it at 350. And what do we get? Here it is, 1 point. Good. So they made $1.2 per latte. So for the instantaneous revenue at 360, what would it be? And the instantaneous profit at 360, what would it be? So you'd say the revenue is much more than the profit because you are not including